We are looking at the exercise questions. Find the general solution of the following. Okay, question one. Question one. We have second differential minus 2 first differential. Okay, so this is we all know the topic is second order differential equation and it's homogeneous. It's equal to 0. Okay, um, the first thing to do is to get the auxiliary equation. So the auxiliary equation, the auxiliary equation is r squared minus 2r plus 3 equal to 0. Okay. Then the thing now to check now is that can we factorize this? Is it factorizable? Let's check. Let's see, as we used to do. Here it is your r squared. Okay. Factors of 3 is 3 and 1. So how do you use 3 and 1 to get your minus 2? That could be minus 3 plus 1. Okay. But when you multiply it, that will be minus 3. What you have here as plus 3. That will make it not to be what? Factorizable. Okay. So we can factorize that. We can factorize that. So what we do now is to use a quadratic formula. So whereby our A is 1, our B is what? Minus 2, and our what? C is what? 3. Okay? And using, and the functions of R, so R is equal to what? Minus B plus or minus B squared minus 4AC all over 2A. So in that case now, my R will be equal to minus into bracket. B is what? Minus 2 plus or minus B squared is 4. And then 4 times 1 is 1. And then times 3. That's minus 12 all over 2 times 1. And this will be equal to R will be equal to minus times minus, that's plus or minus. This will be equal to 4 minus 8, 12, that's root minus 8 all over 2. But I want to know something that root minus 8 implies root 8 times root minus 1. Okay, and root 8 is 4 times 2. That's root 4 times 2. And that will be equal to what? 2 root 2 times what? The radical of minus 1, the square root of minus 1 is a complex number. That's I. Okay, so we're now having we're having our R is equal to 2 plus or minus 2 root 2 I all over 2. So you can take your 2 out. You can take your 2 out, and if you do that, that'll be 1 plus or minus factorize 2 here, take it out. So if you cancel the 1 at the bottom, then you have 1 plus or minus root 2 I. Okay, and that falls into the category of case 3 from the first video of this lecture, where we said when your discriminant is less 0, okay, then your auxiliary equation will produce two distinct complex roots. Okay, if you missed the video, please check it and watch it on this topic. That's the first video there. Okay, so and we said in that case that your auxiliary equation will be alpha plus or minus beta I. Okay, which means your R1 is what? Alpha plus this. R2 is equal to what? Alpha minus this. Okay, and then we said that in that video, we said that the solution of this, okay, that's the solution. Don't forget that the solution is what? Y equal to what? That'll be alpha x cos beta x. That's the y1. And your y2 will be equal to what? Alpha x sine beta x. That's for the complex roots. So these are your solution for the differential equation. So which one is your alpha? Which one is your beta? Your alpha is the what? Is the real part of your complex root. Okay, is the real part of that equation. So your y1 will now become what now? Your alpha is 1, so that's equal to ex, and then cos. Your beta is the complex part, which is the coefficient of your complex number, and that is the what? Root 2. So root 2x. Okay? So that's the y1. Then your y2 will be also the same thing, and then sine root 2x. Okay? So the general solution will be equal to y equal to what? C1 y1 plus C2 y2, which is equal to C1 equal to ex cos root 2x cos root 2x plus C2 ex sine root 2x. So that's the general solution for the differential equation, and that's that question. Okay, that's that question. In a nutshell, when you have your auxiliary equation giving you a complex equation, okay, it's very simple. The real part of that complex expression is your alpha. This is your alpha, and the coefficient to that complex number is all called the beta. Okay, that's beta. Then and that's that on that question. So we'll go to question 2. We have so the auxiliary equation for this question, the auxiliary equation is r squared plus 4 equal to 0. This one has no differential, just with constants. That's why the attachment to your y. That's why you put it through there. There's no differential here. Okay? And don't forget I've said that first differential, your first differential is r, the second differential is r squared, the third differential is r cubed, and so on and so forth. Okay? So in this case now, your r squared is equal to what? Minus 4. And your r will be equal to what? Take the square root of this one, which will be equal to what? Square root of what? Minus 4, which is equal to root 4 times root minus 1. And that will be equal to what? That will be equal to. So since you are taking square root, you are expecting to have plus or minus. So plus or minus 2i. Okay? The root of minus 1 is I. Okay? So that's plus or minus 2i. So in this case now, the real part is 0 here. Okay? We don't have the real part in this case. So alpha is what? Alpha is 0. So the solution y1 of the differential equation will be equal to what? Ex this cos. The beta is the coefficient of I, which is equal cos 2. Okay, plus that's y1, and then y2 is equal to what? This sine 2x. So and that will be equal to general solution will be equal to c1. This one will just be 1, so we have cos 2x here. Cos 2x here. C2 here also 0 times x is 0, and anything to the power 0 is 1. So we also have sine 2x as a general solution for that question. Okay, and don't forget to indicate your plus or minus. So when you take the square roots, okay, the alpha here is 0. We don't have it here, so it's 0. Okay, so that's that on that question, and that will take us to question 3. Question 3. We have a fourth differential. This is fourth differential of 2 times second differential. Second differential. Okay, then plus y equal to 0. So you can put a bracket here. It's second differential. Second differential. Okay, and some books we use that second differential. So that's second thing. It's not y squared. It's second differential. Okay, so the auxiliary equation for this question, the auxiliary equation is r4 plus 2r squared plus 1. The attachment to that y equal to 0. So what we are going to do here, we are going to split this one. You can write that as 2. 2. Want to have it Okay, like this. Okay, then we can pair this one into two parts, r squared here, r squared into two parts. Okay, first of all, 1 and 1. Can you give us plus 2? Yes, 1 plus 1. So that'll be plus 1 here, and so plus 1 here. Equal to 0. And then you begin to solve it. So which means that your r squared plus 1 is equal to 0. The same thing also here too. Yeah, if you solve this one, this will give you r equal to what? Plus or minus what? I. Because plus 1 is going to the other side, that's minus 1. And you're taking square root of minus 1. So that will be plus or minus I. Okay? And the other one also will give you the same thing also. R also is also what? Plus or minus what? Plus or minus I. Plus or minus I. So that's what we have there. So what we do now, we do for this one, it's a repeated root. The repeated roots in complex form. So we solve this one. So the solution of this, we're going to have y1, which is equal to what? We don't have the real part, the alpha. So the exponential is gone. So we only have cos what? Cos. The attachment to the complex number is 1. So just equal to 1 times x. So we will have cos x. Okay? And then we get to y2 for this particular equation. Y2 equals what? Sin x. Okay? Is that clear now? Yeah, let's now go for this one also. So y3, since it's a repeated root, let's do this one. So that'll be equal to what? That'll be equal to y3 will be equal to x cos x. It's repeated, x cos x. Then this one, so y4 will be equal to what? X sin x. So that starts. This is repeated roots. So it will be times x. So the general solution will be equal to y equal to what? C1 cos x. cy1 plus c2 y2, which is what? Sin x, plus c3 y3, which is what? C3 y3, which is x cos x. Then plus what? C4 y4, which is what? X sin x. So that's the general solution for that question 3. Okay, so that you get the solution of this, which is y1 and y2, and the solution of this is what? Y3 and y4. But don't forget, this is repeated root, so that will be what? Times x. So we go to question 4. We have fourth differential minus cos y equal to 0. So the auxiliary equation will be equal to r4 minus 1 equal to 0. Okay, that's the auxiliary equation. So what we can do here, we can split this one into two parts. Okay, minus 1 equal to 0. So this one is a difference of 2 squared, which is equal to r squared minus 1. Okay, into bracket what? R squared plus 1. It's a difference of 2 squared. Okay, so it means r squared. For here, r squared minus 1 is equal to 0. So r squared is equal to what? It's equal to 1. So r is what? Plus or minus 1. Is that one clear? Then this one also is equal to r squared plus 1 equal to what? Equal to 0. Okay? So which means r squared is equal to what? Minus 1. Then r is what? Plus or minus I. The square root of minus 1 is I, the complex number. So then we can get the solution for this expression. We're going to have y1 equal to what? Equal to ex for the positive. Yeah, this is plus 1 or minus 1. And then y2 is equal to what? E minus x. Is that one clear? Then here, the what do you call it? The real part is 0. The alpha is 0. So we can have the y3 here, which is equal to what? Y3 is equal to, we only have the coefficient of I is 1. So we're going to have cos x here. Okay, and then we can have the y4. The continuation of that will be equal to what? Sin x. Okay, so this solution is giving us this one. So the general solution for this one will be equal to C1 this plus C2 y, okay, plus c3 cos x plus c4 sin x. So that's general solution. Yeah, question 5. Yeah, question 5, we have third differential plus 2y prime. The second differential plus y prime plus 2y equal to 0. So the auxiliary equation is r3 plus 2 r squared plus r plus 2 equal to 0. So that's the auxiliary equation. Then we can begin to pair this together, pair this also together. Here, r is square is common, and we have r plus 2. Here, 1 is common, so take 1 out, and that will be r plus 2 equal to 0. Okay, so then you have r plus 2 into bracket r squared plus 1 equal to 0. Okay, so this implies r is equal to here minus 2. Okay, or you solve this one, minus 1, this expression here is equal to 0. So then you're having r equals what? Plus or minus I. I've done this one before in the previous question. Okay, so that's what we have now. So that means the solution of this differential equation y1 will be equal to what? E minus 2x. Then this one will be equal to y2 equal to what? The upper part, the real part is 0 here, so just be equal to cos. And then the attachment here, the beta here is 1, so that's sine that. And the y3 is what? Cos sine this. So the general solution will be equal to y equal to c1 y1 plus c2 y2 plus c3 y3 sine this. So that's the general solution. So that's the answer to that. I just want to observe how they can write your differential. It can be of this form. The y3 can also be of y111. Okay, it can also be like this. It's third differential. Okay, you can see your fourth differential also. So that's the various form of questions, and that is the end of this exercise questions. If you're new on this channel, okay, you can please hit that subscription bell so that as we upload, you get notified. Okay, please join the next video.